Okay, here we're having a look at another one of Chris's simple tests over at ou.com, and the setup is as we have here. I'm using a toroid core. One winding has 28 turns and the other winding has 46 turns, and they are opposing windings. So what I've done here, this end is a start. We've gone around clockwise from this face around the outside and back through the inside, and on the next winding we keep it clockwise but we go through the inside and around the outside. So the two windings are opposite as depicted here. Here and here I have two small light bulbs, as you will see, to give us a visual indication as to what is happening. Here and here I've added two 1 ohm resistors that we're using as our CVRs, which we'll see on the scope. So this light bulb here is our 28 turns, and this light bulb here is hooked onto our 46 turns. The blue channel is on the 28 turn resistor and our yellow channel is on the 46 turn resistor. So apparently what's supposed to happen, I've also added an amp meter here, which is that one right there. So we're supposed to have 2 amps go in one direction, 5.1 amps, and in another direction we have 2.3 amps. So these being wound opposite, as we see here, indicated that these two here are out of phase, and so this is a little test we do. I'm just using a small amplifier. Unfortunately it's not a sine wave, it's a crappy square wave, so it's a modified sine. Cheapo kit from Jaycar, but may have something to do with our load as well, but doubt it. Anyway, we're driving this with our signal generator here, powering by power supply. We've alleviated the common ground issue with the scope and my signal generator there. I'm currently running the scope off my standalone system from the caravan, which you can see down there. We've run the extension cord from the caravan to the scope, so we can now use our scope as though it had an independent ground, which we are doing in this case. 9 volts is our supply of power. 46 milliamps at the moment is our idle draw. You'll see 50 ohm attenuation on the signal input to our amplifier, because it doesn't need very much power for the input signal because it's an amplifier. Alright, so we'll switch on our signal generator. So you can see at the moment both bulbs are nice and bright. 241 milliamps total combined current running through there at the moment. So timed out. First problem we see here is that both outputs from our little transformer are in phase and not 180 degrees out of phase. So at the moment that's actually wrong. Current is flowing in the same direction through both coils, even though they are wound in opposite directions around the core. 104 milliamps through both globes at the moment, so very even, and that is at a frequency of 50 Hertz. So rather than going through all the frequencies, I have been fooling around with this for quite some time now, so I'm just going to go straight up to the frequency I know we see the biggest change, which in this case is 5.6 kilohertz. And once you again, fairly noisy, but our current flow is still in phase. It is not out of phase as was depicted by these arrows. So the current is flowing in the same direction through both of these windings on our transformer at the moment. We do, however, now see that one with the 28 turns does indeed have more current flowing through it than the one with the 46 turns. So this part here is true at the moment. However, it says we should have 5.1 amps flowing through this part of the circuit, which of course is going through our light bulb and CBR, and only 2.1 amps going in. But here we have 220 milliamps total going in, and we have 120 milliamps flowing through channel 2, which is our 28 turns, and 72 milliamps flowing through channel 1. We do not have more current flowing through that bulb than what we have on the input at the moment. Regardless of frequency, I've been right up to 500 kilohertz, at which time everything just stops, and we draw a lot of current with no light output. So that's the results for this little test. So that is incorrect. As we can see, I'll go through both channels. You can see my invert is off on channel 1, channel 2, my invert is off, and you can see I have both grounds on the front side of our resistors, as you would have to have, and the probes on the back side. So that's wrong, and as far as that being more than that, that is also wrong. Regardless of what frequency I drive this thing at, cannot get these results, and we do not get the current flowing in two different directions, or 180 degrees out of phase like one would expect with the windings being asked about phase. They're clearly in phase with each other. So once again, another test carried out, and the results are not what we were told they would be. The only thing that is correct here is that the one with the least amount of turns does indeed have more current going through it than the one with the most amount of turns. I would say that is to do with the extra resistance, and also this here would be screwing up the inductance on both coils. So this one here, the least amount of resistance with the most current through it, would be killing that one with the more turns. So, but even so, even though they're wound in opposite directions, the current still flows through both light bulbs in the same direction at the same time. So they are in phase and not out of phase. Okay, so that's my little test setup. Nothing special once again to be seen here. Of course, if you think there is, feel free to show us. But from 50 Hertz right up to 500 kilohertz, there is no change in phase, no change in the results. The input current is always more than the output through the 28 turn coil, and also more than the output through the 46 turn coil. And like I said, both of these are in phase, not out of phase, so the current's not actually flowing back that way, it's all going this way. So that's the results of my test so far. and I've given it a fairly good shot, but there is nothing special to be seen here that I can see. If I remove the inductor and this circuit and just drive the 2 light bulbs DC current, we use a lot less power to get the same light output. Surprise, surprise. Alright guys, thanks for watching, and we'll see you again next one.